Hello. Yes, I'm audible. Perfect. So welcome everyone to this workshop about regulatory compliance in Web3. Really exciting and scary topic at the same time. So I really hope you will enjoy this workshop. I'm Bogdan, head of product at NexeraID, and I'll be hosting the workshop together with Chris, who's our lead Web3 engineer. A bit about the agenda today. We'll shortly introduce NexeraID and what we're doing at NexeraID so that you get an idea what's our experience with regulatory compliance in Web3. Then we'll look at what are the challenges of regulatory compliance in Web3. We'll look at a few key enablers that help us tackle those challenges. We'll show you a few of our products that we've built to help companies deal with regulatory compliance in Web3. Then we'll have a demo to show you how this will look like from a user perspective. And at the end, we'll have a questions and answers session. So about NexeraID, we're a self-sovereign identity issuance and verification platform that empowers companies to onboard users in Web3 with self-custodial wallets and streamline complex compliance workflows. What this means in practice is that we have a set of SDKs and APIs that get embedded in our clients' applications. And this help manage the full journey of their users in Web3 from onboarding up to compliance verification. So with our SDKs, you can take a user that's a Web2 user. He never interacted with the Web3 world so far. With the wallet SDK, you can set this user up with a private key and a smart wallet. Then with the identity module, the user can build a self-sovereign identity inside of the app and then use it to verify to verify his identity against the rules that the application needs to verify, so that at the end the user interacts with your application in a compliant manner. So our customers are using either one of those modules or all of them to handle the whole user flow. And today we will mostly speak. We will speak mostly about our identity and compliance modules and our experience with developing these tools. Before going further, let's speak a bit about regulatory compliance. So we all know that Web2 financial institutions are required by law to verify things like the identity of their users or the transactions that the users are making against their applications. Well, this type of regulatory compliance very soon will be coming to Web3 as well, and companies that are operating with the help of smart contracts will need to implement the same types of regulatory compliance rules sooner or later. And this brings many challenges to Web3 companies on one hand, and then to Web3 users as well. So let's have a look. So companies that are expanding into Web3 and need to comply with regulatory compliance, need to implement regulatory compliance, face the following problems. They're basically, at this point, there are no proper solution for implementing regulatory compliance for Web3 applications. For a Web3 application, if they would turn to regular traditional KYC or KYT solutions, this would lead to centralization of private user information on their end, which is really against the whole idea of Web3. Also, such solution will not allow them to enforce compliance at smart contract level. Like regular KYC, KYT work well for normal backends, front ends, and whitelisting that happens at that level, but not at a smart contract level. So really no real adapted solution for Web3 at this moment, for Web3 companies. On their end, Web3 users face a set of challenges as well. they need to, users need to KYC for every financial applications they interact with. And in Web3, most of the applications that we're interacting with are some sort of financial application. So this means that users will need to do KYC over and over again for every dApp that they would interact with. And this would, with the old approach, would leave behind a huge trail of data and will force them to disclose their private information, which is really not what we're used to in Web3. But the good thing is that recently we have encountered a set of key, I would say, technical key enablers in the form of self-sovereign identities and in the form of compliance engines. And I would like to describe a bit, so I won't go, this won't be very technical, but I would still like to describe a bit these two key enablers so that you will get to understand our products better. So what we aim to have with self-sovereign identities are identities that are user-owned, portable, secure, and interoperable. And right now, what imposed as the, I would say, the basic building block of self-sovereign identities are verifiable credentials. And they're a system that functions based on the approach described in the diagram. So you would have issuers that can issue verifiable credentials that are then transferred to a holder who will be able to reuse these verifiable credentials against multiple applications, which will verify that those verifiable credentials are issued by the trusted issuer. So, for instance, a holder can ask a government institution to issue him a verifiable credential that proves that he's 25 years old. And then the user will get that verifiable credential and use it in against many applications that want to verify that the user is older than 18. The user will just give the verifiable credential with his age to that application. What verifiable credentials enable are off-chain compliance verification processes that are better than the current ones because it's the user who owns their identities. They can reuse them multiple times against multiple applications. This still happens off-chain, but there's another advantage. They also enable granular disclosure. So if the application only needs the age of the user to verify that he's older than 18, he's not required to also provide his name. He can just provide the verifiable credential with his age. So we have a good starting point, but still the user cannot preserve full anonymity, and also with this solution we cannot do compliance verification on chain. So we need to go further and look for a solution. And the next solution that comes as an enabler are zero knowledge proofs, who are basically a system that enable one party to verify, to prove something to another party without disclosing more than necessary information. And what ZK proofs, in our example from before, what ZK proofs will allow to do is they will allow the user to transform his verifiable credential that proves that he has 25 years old, he's 25 years old, into a proof that, into a zero knowledge proof that just proves that he's older than 18. And when a verifier will ask him for his age, he will, instead of giving him his exact age, he will give the zero knowledge proof that proves that he's older than 18 without him needing to reveal his exact age. So right now we have self-sovereign identities that are adapted for anonymous compliance verification off-chain. So the final component we need to look at is how do we bring all of this on-chain so that the compliance verification can happen at a smart contract level. And there, the enabler are on-chain identities, who are generally represented by non-transferable soulbound tokens, so NFTs. They are published on chain and publicly verifiable. And recently we have technologies that enable us to make this, to add properties to that, to this NFTs in a technology that's called meta NFTs. And what we can do with this, we can basically have the user publish his zero knowledge proof on chain, verified, and then store it, link it to his on-chain identity. And from there, a smart contract, a DeFi protocol can immediately check on-chain that the user has the required ZK proofs attached to his on-chain identity. So with these three elements, we can get into a setup where the user is ready he's set up for on-chain compliance verification, on-chain or off-chain and anonymous compliance verification. But we haven't solved all the problems because this solves the problem for the user, but not for the companies themselves that need to verify a few things about the identities of the users. So in practice, the situation is generally way more complex than checking for the age of the users. What financial institutions in Web2 now need to do, and we can expect to have the same in Web3, is to verify very complex set of rules. They need to look at all the transactions that are happening, and when the transaction is bigger than a certain amount, they need to trigger a KYC verification for the users, and depending on the jurisdiction, the information that is needed is different. So companies need, in order to enable this and to implement this easily, they need compliance engines, which are systems that take self-sovereign identities as an input, and then they can verify them. First, they can verify the veracity of the data, that they were produced by a trusted issuer, that they are correct, and then they would look inside and try to map the information that they get against very complex sets of rules and workflows that match rules and regulations that exist in the real world, like FIA-ATF or MiCA. And ideally, this system should be able or capable to enforce regulatory compliance both on-chain and off-chain. So these are the two, I would say, big categories of enablers that we see, like more and more work is done on this in these two categories recently. And these are also the technologies with which we're working on at NexeraID for the past 6 months. And what I want to do next is show you how we took and worked with these technologies to come up with easy to use a product for companies. So I'll describe our identity and compliance modules and show you how they work, and then we'll see a demo of them in practice. So the NexeraID identity module, it gets integrated through an SDK in the client application. And what it enables is a unintermediated KYC process for the user. So the user will get in direct contact with a KYC providers. Those are the traditional KYC providers that we find in Web2 right now. But the twist is that instead of that KYC provider being keeping the data, the KYC report of the user on there and or submitting it to the client application, instead of that, the KYC provider returns the data directly to the user, and only the user can hold that data. And moreover, that data is transferred to the user in the format of verifiable credentials. So he's basically able to hold that data and submit it to applications and disclose only the parts that he wants to disclose. And in addition, the user can build zero knowledge proofs based on that data and publish them on chain. So he can build a full self-sovereign identities very easily. Yes. Then the second SDK that we provide also gets integrated in the client application, and it enables the client application to request specific data from the user. and it's the user himself who decides to what type of data he wants. He will be able to see what type of data the application will ask him for, and the way that he wants to reveal it, either as verifiable credentials or as on-chain ZK proofs or off-chain ZK proofs. And the data gets submitted to the application, and our compliance SDK forwards it to our rule engine, who's able to verify that information against a set of rules and rule templates that match a regulatory compliance that are of interest for the company. And moreover, the rules engine that we have enables easy creation, publishing, and using of custom rules. So if the company wants to have some very specific rule for themselves, they can build it, publish it to the rule engine, and it can be used in the compliance verification process. And by the way, this can go like some rules can have nothing to do with necessarily with the compliance. So it's very flexible. We can check many different things. And so just to see the big picture in practice, both of these SDKs will get integrated by the client application, and the whole process will happen in 2 steps for the user. You'll see in the demo in a second as well. The user will first use the identity module, or through the identity module, he will get in possession of verifiable credentials, ZK proofs on-chain, and move that on-chain. And then in the second process, the user will submit his information. The application will ask the user for his information, and he will submit it. If that information matches the rules described in the rules engine, the user is allowed to interact with the application. If the information is not matching the rules, the user is fenced out of the application. There are multiple things happening there, but I think for now we can stop here with the description and go to the demo. And then if you have questions at the end, I'm gladly to respond. I'll gladly respond.
Hey, can you hear me? Yeah. Should be better now? Yep. Thank you. Okay, thank you, Bogdan. I'm Chris. I'm a lead developer on the Nexera product. And today I would like to show you a quick demo. This demo is a mock Uniswap application. It's actually an institutional Uniswap application. And what we will do is 2 steps. In first step, we will verify our identity off-chain to access the application itself, to see the UI to trade. And then to interact with the smart contract, we will verify our identity on-chain using zero-knowledge proofs to enable the smart contract interactions. So we click Get Started, and we verify ourselves. What you're seeing now is a KYC module by the NexeraID. When you click Start, the KYC session is started. Okay, so the user has an option to scan the QR code and complete the session using their mobile phone. In this demo, I will be uploading a test ID card. So in this KYC process, the data is extracted from the card, populated for the user. We also have a liveness check. A liveness check requires us to take a selfie. Okay, it worked. Seems like I'm a human. Okay, so now the KYC process has been completed. We will see the input forms where we can modify the data if the process extracted it incorrectly. But in this case, everything is correct. So we input the country of residence. Click Next. Now this is the important part. We sign this message, meaning that we are connecting our MetaMask wallet to this KYC report. This means that another wallet cannot just reuse this one and so on. And now we are sending it for the verification. We can also download this KYC certificate, so we can import it later. The KYC certificate is encrypted and can only be decrypted with a MetaMask signature. Actually, it's not just MetaMask signature, but any private key signature. And we finish. Now, this is important here is this SDK module was configured so that it complies with what the Uniswap needs. So in this case, the Uniswap institutional application requires to send nationality and our residence. Some other application can require other information, and all of this is configurable using the SDK. So we click Share Data. Okay, perfect. Now the data is being verified by the rule engine, and if you refresh the page, we should, a few seconds. Yeah, now we can see the UI. This means that our KYC process was successfully completed. The data was sent to the rule engine. The rule engine evaluated this process that, okay, this is a person that can interact with the application. But now, this is just the off-chain part. We still cannot interact with the smart contract because also the smart contract is protected in a way that it checks the meta NFT properties if they contain those ZK proofs that Bogdan was talking about. And now we will do this ZK proof part. So, just wait for the UI to load. Okay, so when we click Verify Identity on Chain, we start up the KYC module again. Here is important, when we click on the ZK proof parts, we have this drop-down. This KYC session is the KYC session that we just completed. So we can see that we can reuse the KYC for different parts. If we would have another application, this KYC session could be reused for another application as well. So based on those verifiable credentials, we will be generating ZK proofs. Now again, this is again dynamic. The Uniswap institutional application, the smart contract, requires us to have two properties. One is that we are not from the US, and another one is that we are not in a high-risk country. So when we click a generate proof, under the hood, we run a zero-knowledge circuit based on the verifiable credential data, and now this proof can be published on-chain. When we click publish, we get a MetaMask pop-up, and we click confirm. And now for the second one. Confirm. Okay, so we generated both proofs and we published them on-chain. So now we can close the KYC session. And we can see that the button already changed to a swap. We have this check that checks on the contract if the swap would fail or if it would not fail. Now we can see that the swap would go through. So we can swap AVAX for USDT. Swap 0.1, swap. We get a MetaMask pop-up. We confirm the transaction. And we just completed a trade that is KYC and compliant. That's all with my demo. Thanks for...
Yep, so that's everything for our presentation. We still have time for questions, so don't hesitate.
Yeah, hello. Quick question. So where does user store these credentials between passing the QAC and actually generation of on-chain proofs?
Yeah, so far we developed a browser storage, which is encrypted. So when the user completes the KYC, the data is stored in the local storage of their browser. It is encrypted with a MetaMask signature. So every time the user wants to access this data, it needs to be decrypted to be present. And then we also can support exporting and importing. And then however the user exports, it's up to them.
Thank you. Yeah, importing and exporting would be really great because if user need to change browser, change device,
go to another application that also embeds the KYC module. So yeah, that's how the user will basically transfer his verifiable credentials from one browser to the other, from one application to the other. Of course, the on-chain part is automatic. That will always travel with the user and with his MetaMask account.
To understand from you in terms of, for every new field, will there be a new circuit required? and will the circuit is generalized in nature. So if we take an example of a user is an institutional user and has licensing to trade a given security in a market. That's a very specific action which they can take, which is linked to basically for that license, it only allows you to do transaction in a particular country. Whereas another example can be of the size of the transaction. If you are an institutional versus a commercial player, will you be allowed to buy a 5 million versus 100 million versus 10,000? How will you see those kind of constraints and what will be the circuit requirements?
Okay, a good question. We built basically two zero circuits, zero knowledge circuits that act like a building block. One circuit allows us to prove something that is in a group or that is not in a group. So, for example, this way you can prove you are a participant in a group of countries or a group of jurisdictions, or that you are not participant in those groups. The other building block is a proof that lets you prove that you have a number bigger or smaller than another number. And then you can combine those however you want. Then I'm sure there are use cases that those two building blocks do not cover. But in those cases, yes, the circuit would need to be recompiled. But I don't think that's a big problem. And the system should support any number of circuits. Yeah, yeah, Snark.js and Circumlip for building the proofs.
To me, you mentioned there's a rule engine, and how do you handle privacy with that one, right? Because the rule engine has to have access to a lot of data, like just the rules and the data that they process. If I am a company and I want to have compliance with MiCA and I have 18 months left before I need to actually have compliance, how does it work?
Okay, so the rule engine is based on Open Policy Agent. Open Policy Agent is an open source software for enforcing rule policies. It is service agnostic, language agnostic, so you can use it with whatever language you use it. It's API based. We built a set of policies that can be just reused, or you can build your own policies. The language that is written is called Trego, so it's pretty well known, I would say. And we offer two modes. One mode is that you send the verifiable credentials of your user to our API, we evaluate the rule, and then we give you the result of the rule. The other option is that you call our API and we compile you a bundle. This bundle is basically a way to execute the rule without the Open Policy Agent. So we just return you a package. You can run this package using WebAssembly, and then this WebAssembly will run the rule. And then this rule can be run in the browser. It can be run on your servers. You can run your own Open Policy Agent in your Kubernetes cluster, for example. So the possibilities are big.
The question is so the storage is off-chain, basically?
It's up to you. So if you need to have privacy, then you download the rules from us and you run it on your site. If you don't care about that privacy, then you run the rules on our site. And then there is also a decision logs service, which basically outputs a log for every decision that the Open Policy Agent creates.
Thanks.
Is there any unencryption permissioning outside of the MetaMask user that, you know, if OFAC wants to unencrypt a particular piece of information to get the passport and the actual identity, is that baked in?
Yeah, let me just come back to the diagram. So there's a flow that I didn't describe initially, just for us to go faster. But what the compliance engine also allows to do, and the compliance SDK allows to do, is it allows the company if the regulations are requiring the financial institution to also store the data of the user for later reveals, they can do that with a compliance SDK. They can store it, encrypt it in a storage on their premise, and they'll have the keys to decrypt that data if a regulator asks them to provide that data. So it's a functionality that's baked in. We activate it only in cases in which companies really need to do that because regulations are requiring. Hope that responds to your question.
Obviously, keen to reduce user fatigue. Do you think that you could implement soul-bound tokens from other providers and come in midway in the process?
Yeah, that's the thing. On the technical level, it's possible. So what we're using behind the scenes a lot is the what we call the meta NFTs, which are this on-chain data containers. And what this enable is storing properties or like storing properties on chain on this meta NFT. And basically, like in our what we showed just before, we were storing the ZK proofs on that NFT. But what we can do is store other soul-bound NFTs or link other NFTs to it, so that basically we can bring other soul-sovereign identities linked to this one. So this can easily be enabled through this technology. Yeah. Yes. Mm-hmm.
Is there a service which you guys provide for the subnet itself? Subnet provisioning, and you can do this provisioning at the chain or the app chain level?
Right now, we didn't investigate that much time into this, but I'm sure it should be possible. Our solutions are API based, so I suppose it shouldn't be that hard to do it.
What we've explored a bit more is bridging of this soul-bound token from one chain to the other, together with the properties that were stored on it. So we can talk a bit more about that in private afterwards. So yeah, I think we're done, unfortunately, but we'll be here for more questions. Thanks, everyone.